Hey guys, today we're talking about graphing quadratics. So if you would remember back, we have a standard form of a quadratic, which is f of x equals ax squared plus bx plus c. And again, that's the standard form. Also remember that f of x is just another way to say y. And normally we're used to something that just has the bx plus c, and that gives us that nice straight line. But when we add this ax squared in there, it's going to give us a different shape. So the type of graph we're going to get is called a parabola. And we actually talked about parabolas a little bit last year in 7th grade with nonlinear functions. So a parabola shape, and you may or may not remember this, but we will draw it again. So let me get my coordinate plane here. And a parabola will take the shape kind of like this. Basically makes a nice big U shape. Okay. And a few things we like to find on a parabola. One would be the axis of symmetry. And we have a nice little equation for that. It's x equals, because it's a vertical line, negative b over 2a. So whatever we have in our formula for b and a, we will stick that in here to find the axis of symmetry. And then the y-intercept is always going to be that c, that point. Okay? So a few other things we can learn from this. The parabola doesn't have to open up like my one I just drew did. They can take a couple different shape or forms. So if a is positive, we're going to have an open a parabola that opens up. Or a U shape. And because it opens up, this point down at the bottom is a minimum. It is a minimum value. And then if a is negative, we have more of an N shape or an upside down U. And the highest point on this graph, right there at the top of the upside down U, that's going to be a maximum. Okay. So let's do an example where we kind of try to find some of the things we've talked about. So we'll start off with an equation, y equals 2x squared plus 4x minus 3. And remember, we're going to try to find a couple different things. The first one being our axis of symmetry. We're going to try to find our y-intercept. We can, once we have the axis of symmetry, we can also find the vertex. And we can label that as a max or min. Based on if we know it opens up or down. Okay? So let's see what information we can glean just from looking at this formula. Well, we know that this 2 is positive, so that a equals 2, which is positive, which means it should open which way, up or down? that it opens up, which means our vertex is going to either be a max or a min. Because it opens up, do we think it's going to be a maximum or a minimum? Good, it should be a minimum value, okay? For our axis of symmetry, we need negative b over 2a as our formula, and that's equal to x. So we'll start plugging some stuff in. So we'll plug in negative times 4, because 4 is b, over 2 times a, which is another 2. So we have negative 4 over 4, which simplifies to negative 1, right? So our axis of symmetry is going to be x equals negative 1, and we can box that in as our answer. And once we have that axis of symmetry, it makes it really easy to get our vertex. And how we find our vertex is we just plug this in every time we see x. So we have our equation 2 times negative 1 squared plus 4 times negative 1 minus 3. So negative 1 squared, of course, gives us 1. 4 times negative 1 is minus 4. Minus 3, here we have 2 minus 4 minus 3. And we do have to do this from left to right. That's why I didn't go ahead and combine those. 2 minus 4 is negative 2 minus 3, which would give me negative 5. So my vertex is a point. It's where that minimum point is. And so I need an ordered pair. Remember, we plugged in x equals negative 1, so that's going to be my x value. And my y is what I just found, that negative 5. So that's my vertex, which is a minimum. And the last thing I want to find is my y-intercept. Again, a y-intercept is a point, and it's where it crosses the x-axis. I'm sorry, the y-axis. If it's crossing the y-axis, the x-intercept is, or the x part of that y-intercept, I'm sorry, is always going to be 0. And then the second part is that c, and we've said that on the last slide as well. And my c here is negative 3, so that would be my y-intercept. So I found really a lot of different things here. From the a, I found that it was going to open up, which meant it was going to be a minimum. I used my formula to find the axis of symmetry, and I got x equals negative 1. I plugged that into the equation to help me find my vertex point. And then I used that c value to find my y-intercept point, which is 0, negative 3. So I really used every part of this equation, sometimes multiple times, to figure everything out here. The next thing we want to talk about is solutions. Because we want to know solutions to a quadratic, that ax squared plus bx plus c. And so looking at the graph can give us different solutions. So we'll have 3 different examples. So if I have a graph that, whether it opens up or down, it doesn't really matter, but it touches the x-axis 2 times, at these 2 points, I'm going to get 2 real solutions. Sometimes it doesn't touch twice. It may only touch this one time at the minimum or the maximum, whatever it may be, depending on how it opens. And then I have one unique real solution. But lots of times, it may not touch the axis or the x-axis at all. It'll touch the y-axis eventually, but it might not touch that x-axis at all. Maybe the minimum or maximum is just not on the line and it's pointing in a direction that it's away from the x-axis. So if it's not going to touch the x-axis ever, we would call that no real solution. So let's try a couple different examples. I am going to start with an equation, x squared minus 2x minus 8 equals 0. That'll help us graph it. But before I graph, I want to find the axis of symmetry, the vertex point, and the y-intercept. So we'll go through these one at a time. See if you can find the axis of symmetry on your own. Good, you should have picked 1, or x equals 1. Once I have that, I can plug that into my equation to find the vertex. For your vertex, you should have picked 1, negative 9. And finally, my y-intercept. Good, hopefully you picked 0, negative 8. So the next step would be to go ahead and graph this. So I'm going to have my coordinate plane over here. It's a big axis. And I'll start kind of labeling different things on here. We'll go across 1, 2, 3, negative 1, negative 2. And the easiest way to kind of graph it is to graph some points I know. So I know, for instance, the y-intercept is 0, negative 8. So I'm going to go draw my y-axis a little more. Here's maybe 2, 4, 6, 8, 10. So I'll plot my y-intercept, 0, negative 8 is here. My vertex, or my minimum, is going to be 1, or I'm sorry, my minimum is going to be 1, negative 9, which is down here. Which means this is going to be where my axis of symmetry is. All the way up. And whatever points I have on the left are also going to be on the right. So if this is 1 away, but at negative 8, I'm going to have one at 2, negative 8. And then I can create a t-table to kind of find some other points. So I also, I just kind of happened to pick and draw it, but at negative 1, y will be 0. And at 4, y will be 0. So here's where I have my points where it crosses the x-axis. So I know that 4 and negative 2 should be, sorry, it shouldn't have been negative 1, it should be negative 2. So 4 and negative 2 are my solutions to this quadratic. And of course, I'm going to finish off by graphing it like so. Okay? So let's try this next one. So you'll notice it's not quite set up the same. It's not equal to 0. So I need to move this 49 so it is equal to 0. So I'll get x squared plus 14x plus 49 equals 0. From here, I want to find my axis of symmetry, my vertex, my y-intercept, and I'll have you find those. And I also want to find where it touches the x-axis, so my x-intercept kind of. And that I can get more from graphing. So you'll want to set up a t-table of x and y values. You know, if x is 0, what is y? If x is negative, or if y is 0, what is x? That kind of idea to see where it crosses. And from this, we kind of, once you found the vertex, or the vertex, you had your solution, because it's going to hit just at the x-axis where this is negative 7, and that would be my solution, would just be that negative 7. Thanks for watching.